Hey everybody. All right, so today's lesson we're going to do partial fraction decomposition. We're skipping around in chapter 8 a bit, so don't worry about sections 2, 3, and 4. Partial fraction decomposition, you'll see what it is. So if we have two rational expressions like this that we're adding together, we know we have to get a common denominator so that they have the same denominator. Now that we can actually add them up, distribute, combine, and we're here. We know how to do this. This isn't all that complicated. Our goal now is to start here and get to here. So we actually want partial fractions. So we want to be able to break it down, to decompose it, as it were. So in this chart here is quite nice. Most of the time, like the example we just did, they're based on linear in the denominator, meaning we just have x to the first power. If we have duplicates of the or multiplicities of the linear, then we actually have to set it up like this. Because if we add those two things up, that's the LCD. If I add these up, that's the LCD. If they're all there, that's still the LCD. So we're just going to assume that these are all there as we set it up. If we can't factor a quadratic, then we set it up like this. And we'll run into one of those, and I'll show you what I mean. And now here's multiplicities of a quadratic that doesn't factor, and you can see it's kind of the same thing. Notice we have a second degree down here, and we have a first degree above. You can see we have that as we're looking at that. One more concept before we can jump into an example. What we're going to do is we're going to eventually get it down to here equals here. And you can see that the x squared terms, their coefficients have to be equal. So a is going to have to be 3 in that case. Here, x to the first power, their coefficients also must be equal. And here, the one without an x, those also have to be equal. There's a math reason for that. It's not super complicated, but it's definitely outside the scope of this course. Now, we know from our example up here, we're going to break this one down. We know what it should be when we're done. So here's what I'm going to do. We're going to start here. And we're going to assume that this breaks down into a over that plus b over that. And what I'm going to do now is I'm going to multiply both sides all the way through by the LCD. LCD in this case is x plus 2 times x minus 4. And when I multiply that to this side, I'm just left with the 10 plus 2x. They both get reduced out. Here, the a, it reduces the x plus 2, but it's left with an x plus 4. This one, the x minus 4, gets reduced out, and I'm left with an x plus 2. I distribute the a's and b's, and I rearrange them. So I'm going to arrange the ax and bx to be together and factor the x out. Same with the last, these two terms here. I'm going to group them together. And now we're going to do that same thing we did. The coefficient of x has to match up. There we are. The coefficient here has to match up here, and you can see I have that here. I now have a system of two equations, and when we solve that system, which you can certainly do, we end up with a equals 3 and b equals 7, as we know that it should be. Let's try another example. Now, here we're going to do one where they're linear, but we have multiple powers, multiplicities. So we're going to assume this gets broken up into a over x plus 2, plus b over x plus 1, just to the first power, plus c over x plus 1 squared. So if that was third power, we would have a d over the x plus 1 to the third power, but we're going to stop here. We need all the previous. And now we're going to actually add them up. And you can see our numerator here. So we get a common denominator. This was missing from here. Those are missing from here. And this, only the x plus 2 was missing. Combine, distribute, and what we're going to do, we have the a plus b. Can you see I have like a 0x squared up here? So that's where that 0 comes from. The x squared coefficient is 0 up here. And that's why we got 0. This is a long problem. Which implies this when we subtract the b. Next up, you can see the coefficient of x here is going to be 1. Coefficient of x here is 1. And this last grouping here is going to match up with -3. And that's where we get that's equal to -3, this last part. Now I have a 3 by 3 system. I'm going to substitute in to here, -b plus 3b. Combine those up, I get b plus c equals 1. That's here. Plug -b into here. Combine up your like terms. So now I have two equations with two unknowns. And now we're going to solve that system. Subtract the bottom one is fine. You get c is -4. Plug that in. B is 5. Now you're going to take c and b, plug it into, oh, we know that a is -b, so a has to be -5. You may need to go through that one again. All right, next up. Here we have a non-factorable quadratic. So if you look at that first page, non-factorable quadratic becomes this with a linear up above, x to the first power. And you can see that's what we did. Again, get a common denominator. This is missing from here and that's missing from there. Distribute and combine and group it up. So now I have the a plus b. You see there's no x squared up here? That means it's equal to 0. Here's the coefficient of x. You'll notice there's no x here either. That's also going to equal 0. And last up, we have the a minus c. That's going to match up with the 2 there. So here are my three equations with three unknowns. So here, I can take that, I can add these up, and you'll notice the b's reduce out completely. So now I have one with an a and a c. If I take equation 3 and 4, so here's 3, and here's 4, and you can see this has an a and a c, this has an a and a c, so now I have these two equations to solve the system. And when I add those up, those c's go away. I get 3a is 2, a is 2/3. We can see from the first equation up here that b is -a, so -a is here, so here's b, -2/3. And then we go back to here, right there, the a minus c equals 2. Replace the a with the 3/2. 2/3, I keep saying that, 2/3 minus c, subtract it and divide by -1. So we replaced all the way up here, a with 2/3, b got replaced with -2/3, and c got replaced with -4/3. And I don't really like having fractions like that in there, so I multiply the top and bottom both by 3 to get rid of all those denominators. So all those 3's get knocked out, and then there's my extra 3's down there. And that is that broken down.